Today we are going to talk about our group presentation, and our group name is Pipecloud Group. We have 7 group members, and here is our GitHub repository. You guys can have a look at this repository. And so today I will start my presentation by second different point, and we have our purpose and our data description and also data infrastructure, and followed by most importantly with the data engineering and ETL pipeline, and also the advantage and disadvantage of ETL in each technical stack. And finally, we'll have some discussion about data science modeling and our future work. So let's start with the purpose. We start our project by having an aim to make demos for entrepreneur level data warehousing and data lake building. So by doing this, we set up 8 different tasks. The first one is to build data lake, and second one is data flow coordination and integration. Third one is to have some real-time data processing, and fourth one was to have some was to build a data model, and fifth one was using big data engine, especially the data engine in Amazon SageMaker. And the sixth one was to develop the data product, which is to make sure every component can combine together. The seventh part was to build a machine learning model, which we set it up in SageMaker. And the eighth one is to have an online recommendation system. So we also try to cooperate with other team members to develop a frontier and UI and interface, but it's still in progress. So as the data description shows on the graph, we did some primary data visualization. The first diagram is to show is the 30 most first order products. By building this diagram, we can help our system to have a cold start, which means if the customer hasn't bought anything, we can still give them some recommendation. For example, if most of the customer would buy banana, then the cold start customer can also be recommended a banana. And the second diagram is the heat map of the count of orders in each day with each hour, which makes us able to focus on the most important part of our data, because we need to focus on the orders. So if we know in which time the most orders can be generated, we can manually see some data. And here is the data infrastructure that we use. There are 4 different CSV files. And here's the data diagram that we built. So let's move to the most important part, which is the data engineering and the ELT team process. We actually built our data pipeline in 3 different ways. The first one was the AWS Glue and the Amazon S3. And the second one was the Snowflake. The third one was Databricks. And we do the machine learning on AWS SageMaker to predict results after we finish these 3 different ELT team process. So let's start with the first one. It's the AWS Glue. As you can see from the diagram, that the 3 different solution will be connected to S3, and then all the result will be sent to SageMaker to calculate. That means we have tried 3 types of ETL process. We'll show these 3 solutions one by one. The first one, the AWS tool. So we separate our AWS data structure and pipeline into two parts. The first one is the AWS data lake system on the left-hand side. In this data lake system, we have Amazon S3 and also the Lambda function to trigger them, and also AWS Glue and the Glue databases. Those components combined to our data lake system. And in the AWS cloud, there are also some tools that we use to generate our machine learning model. The most important one is the Amazon SageMaker. You can see on the number 4, the Amazon SageMaker use the Amazon training instance to calculate, and the instance we used was machine learning model 4 large. And Jupyter Notebook is the most important IDE that we use to write our data. And after that, we use the model endpoint to deploy our model. The model endpoint will send information to AWS Lambda, and Lambda will connect with API gateway to make sure the web service can receive some information. And the arrow shows the connection between API gateway and the Lambda function we use. So let me be specific and focus on the data lake system. In this picture, we use the draw.io to show everything about our data lake system. So from the very beginning, the customers will provide raw data to S3 data source. And then we extract raw data from data source into data lake by using two kinds of Lambda function. The first one is the event trigger Lambda, and the second one is the schedule trigger Lambda. For the event trigger Lambda, we will have some CSV files like orders and data order per hour, data order train, because this part of the CSV file can be triggered by event. For example, if the customer sends some new orders, the trigger will be triggered. And if we look at the products of CSV and the department of CSV, those files are more stable so that we don't need to constantly change them. After we store all those data, we use the event trigger S3 trigger caller to activate the glue caller. And this one is the most important part for AWS Glue services. Because the caller, we can have a database on Glue. And because we wrote an event trigger core triggering Glue ETL job, we can start to use Glue to generate some new CSV files. For example, in the feature data zone, we have user feature 1, user feature 2, and up feature and predictive features. And all those data can be sent to our business intelligence part to do data science modeling. And for those Glue job, we can also send our data to crowded data zone and use an event trigger S3 trigger SageMaker to start the XGBoost SageMaker. For the 5th part, the SageMaker reads the wide table as training dataset and feedback the machine learning model. We start this by I think it's I think we use a life circle system to trigger that. And this part was the first part of the ETL pipeline that we finished. The reason for us to choose this solution is that AWS cloud service is commonly used by enterprise, and it's enable us the ability to build web apps. For this solution, the advantage is to have enough resources and have multiple functions. And we can search for sufficient computing resources and customer support. But the disadvantage is that AWS cloud services is not so user-friendly. So our future work was to enable some streaming data to be run in the AWS data lake, and also to enable Airflow workflow system. And next, we would like to introduce Databricks. Let's welcome the Mengzhe to talk about the Databricks.
Hello everyone, this is JRMel. Today I will introduce the Databricks ETL pipeline part of my group job. Firstly, in this picture, it shows the whole ETL progressing in Databricks. In Databricks, I used credential configurations to connect to S3. Then after update and clean the data, I create a DLT pipeline in Databricks. Here I will introduce some about the Delta Live Table. Delta Live Table is a framework for build a reliable, maintainable, and testable data progressing pipeline. Define the transformations to perform on data, and Delta Live Table manages the task orchestration, cluster management, monitoring data quality, and error heading. After the pipeline progressing, the data will be saved in two ways. One saved in Hive metastore in Databricks for future test. The other one saves as a PACRI file and sent to S3 for next machine learning part. Next page, please. Next page. Hello. Hello, hello.
组长在吗？
在的。
下一页。
我这边是有在翻页，但是它是
好，
这个可以。
OK。
可以。This page shows all the tables I created, calculated, and joined in pipeline. At the same time, this is also the demonstrations of my achievements. Next page, please. Here I will talk about some advantages and disadvantages of Databricks. The advantages of Databricks are the bench and the stream data can be built in same pipeline. This can be set up because of the autoloader and the CDC, which names change data capture. The autoloader can read data for supported file format, particularly for stream live table that operate on continuously arriving data. The autoloader is scalable, efficient, and support schema inference. The change data capture use apply change method to make sure data can be transformed continuously. The disadvantage of Databricks is limitation and expensive. Although Databricks can support Spark and SQL, its PySpark language is much better than the SQL language. The other disadvantage is expensive. As Databricks is third-party, it uses AWS EC2's instance, and it costs the instance again. Next page, please. So in this page, I listed all the important events of orchestrated in my use of Databricks in a flowchart. At the beginning, I found I want to get data from AWS, from S3. I need more configurations. After that, during the loading data and data cleaning, I found the data is already cleaned. Then I start to build my pipeline. In Databricks pipeline, I can't use normal Sparks. After learning from Databricks documentation, I know the pipeline uses a different way called Delta Live Table. Now I started my first try. The first big problems I met is I can't load the multiple tables. After a large amount of research and tests, at last I know the DLT need to write all the codes in one cell of notebook. After loading data and the simple join, I was thinking about what if the new data came in, how to replace, override to append. After reading the document, the first way I found is autoloader. At that moment, I didn't notice the autoloader is working for stream data, so the autoloader didn't pass the test. Then I changed my mind. I started to think, is there any way to keep the data? Can I merge all the input data into a new table? Then I found a way called CDC. It used the function called apply changes to merge all the input data to a new table. After using these two ways, I optimized my codes. At that time, I suddenly realized that I built a pipeline can upload, stream, and bench data at the same time. At the end, the pipeline's output can be the machine learning's input. The pipeline sends the Pipecloud file back to S3 for future machine learning. In future work for Databricks part, I still think I can optimize my pipeline, reduce duplication and of data transform. This is all my part. Thanks. Next is Snowflake's part.
Okay. Thank you, Rex. And hi everyone. I am Elvin. I would like to talk about the ETL process by using Snowflake and Apache Airflow. The data source were uploaded to Amazon S3 buckets. We extracted the data from Amazon S3 bucket to Snowflake, and we combined dataset by using SQL in Snowflake. After that, we unloaded the new table to S3 bucket. This data was sent to the Amazon SageMaker for machine learning process. Apache Airflow was used to alter, monitor, and schedule the workflow of these processes. Next page, please. In the context of Airflow, a data pipeline is created as a DAG, using Python to define the DAG. And the DAG file defines tasks and the dependency between tasks in the pipeline. Next page, please. As shown on this screenshot, there are 5 tasks in total. The raw data ingestion extracted the CSV files in S3 and loaded them into the Snowflake. Then we did some data transformation and cleaning in the task feature table creation. Finally, we created the machine learning ready final table and unloaded it to the S3. After these tasks, we check the final table in the DAG log, which is shown on the next page. Next page, please. Sorry, previous page, please. Next one. Sorry. Yeah. Actually, sorry. We can see the first 10 record of the final table, and we can also see the columns features in the final table. Next page, please. Here is some advantages and disadvantages of using Snowflake. We can use SQL on Snowflake and its shallow learning curve for using SQL. Due to open source of Airflow, the cost of this process is the prices of Snowflake, Amazon S3 bucket, and SageMaker. Therefore, we use the lowest cost among these 3 technical. Well, Snowflake can run in the AWS, but is not a native offering. Each of these public clouds offer its own data warehouse solution. For example, like Amazon is Amazon, AWS is Amazon Redshift. And another disadvantage is Snowflake only supports structured and semi-structured data. And also the Spark And also the Spark SQL is hard to migrate to the Snowflake. Our next speaker is New Yue, and he will talk about modeling and model deployment.
Next page. Oh, okay, this page. In this section, I will introduce the basic framework for data transfer in machine learning. This part is mainly divided into 3 parts: data extraction, model training, and subsequent model deployment and simple user interaction. This picture has been introduced by my other team members before, and I only cut out the relevant part and put it here. First, we created a Lambda event trigger, and every time a new dataset is uploaded to the S3 bucket, this Lambda function will trigger the subsequent machine learning program. In the second part, we choose the AWS SageMaker service to perform data pre-processing, model training, model evaluation, and model deployment. So SageMaker is a mature cloud-based machine learning platform that supports many machine learning algorithms and many API tools to help us quickly deploy and train models. In addition, relying on the same AWS cloud platform, we can also realize real-time processing of data and the subsequent operation and maintenance work. At the beginning of the SageMaker's operation, we firstly generate code to make the program only take the latest dataset in the folder of the S3 bucket, where dataset is located each time. The specific method is to specify a timestamp to identify the time of the file when naming the file. For example, use a format such as year, month, day, hour, minute, second to name the file. In this way, there will be a file name with the timestamp in S3 bucket, and we can get the latest file through simple coding. We have chosen the SageMaker XGBoost model and selected the machine learning M4 X large instance. The training model will be stored in our data lake. And next page, after the model is successfully deployed at the endpoint, we use the AWS Lambda and AWS API Gateway service to connect the endpoint with the client. And we can realize the direct interaction between the product and the users. At this time, the client only needs to send the user's feature information, and our product will return the predicted result. That is, whether the user intends to purchase the product, and the result will be displayed on the client interface. Well, that's all for our presentation. Thank you.